Image classification with KNN. KNN is a classifier and is short for K nearest neighbor. It is one of the simplest classification algorithms. KNN classifies the unknown data points by finding the most common classes in the K nearest examples. It finds the closest match. Now, if 2 points are given on a plane, one set is a class of dogs and the other set is a class of cat. If an animal is added on the same plane, what will be the group of that animal? We give the images labels. Y equals 0 for cat. Y equals 1 for dog. We will concatenate the 3 channel images to a vector, or you can do the same for grayscale images. In the video, we will use 2 dimensions so we can visualize what's going on. Let's use a 2-dimensional space to represent the images as vectors. We will use colors to represent the classes. We add a bracket around x to indicate axes of the variable. We can calculate the Euclidean distance between 2 images as, that is, the length of the vector connecting the 2 points. We have a set of images. We will refer to them as training samples. If we have an unknown sample, we calculate the distance between each image. Let's put the images in a table where each row is a sample. The second column is a class. The final column is the distance from each sample to the unknown point. We will use the distance to predict the label of the unknown class. As this is a guess or prediction of the class, we use y hat. The hat means it's an estimate. We calculate the distance from our unknown sample. We find the nearest point or nearest neighbor. We assign the label to the unknown sample. We sometimes call this a model. KNN is simple to code yourself, or you can use a software package like sklearn. We repeat the process for the next unknown sample. How do we know if the model works? Separating data into training and testing sets is an important part of model evaluation. We use the test data to get an idea how our model will perform in the real world. When we split a dataset, usually the larger portion of data is used for training, and a smaller part is used for testing. For example, we can use 70% of the data for training. We then use 30% for testing. We use a training set to build a model. We then use a testing set to evaluate model performance. When we have completed testing our model, we should use all the data to train the model. Accuracy shows us how good our method works, that is, the average number of times our model got it correct. Let's use the following table to calculate accuracy on some test data. The first row in the table denotes different sample numbers. The second row shows the actual class label. The third row is the predicted value, and the final row will be 1 if the sample is predicted correctly, or else it will be 0. We count the number of times the prediction is correct. We then take the average to get the accuracy. Finding the nearest samples does not always work best. Consider the following in our 2D space. The cat is next to a dog that looks like a cat. But all the other samples next to the samples are cats. To handle this, we find the K closest samples. We then perform majority vote, where, with the in subset, we find the class with the most number of samples and assign that label to the unknown sample. Let's do an example where K equals 3. As before, we calculate the distance. We select the K nearest samples. As there are more red samples, the new label is assigned to the red class. Let's see how to select K. We use a subset called the validation data to determine the best K. This is called a hyperparameter. To select the hyperparameter, we split our dataset into 3 parts: the training set, validation set, and test set. We use the training set for different hyperparameters. We use the accuracy for K on the validation data. We select the hyperparameter K that maximizes accuracy on the validation set. We use the test data to see how the model will perform on the real world. In this course, we will combine the validation set and test set to make things simpler. Let's do an example. In this example, we take 2 samples. We calculate the accuracy for K equals 1. We calculate the accuracy for K equals 3. We select K equals 3 as it has better accuracy. If our dataset has enough samples, we expect this accuracy in the real world. Once you choose the value of K, you can use KNN to classify an image. Let's say you build an app to recognize cats and dogs. You let K equal to 3. You take the photo. Under the hood, your app will calculate the distances. Find the nearest neighbors, and output the class as a string. Finally, it's simple to add another class, for example, fish. The result would look like this in our 2D space. KNN is not usually used in practice. KNN is extremely slow, and it can't deal with many of the challenges of image classification. So let's learn about other classifiers.